Hello, this is Chaganti, Dr. Bhaskar, working on renewable energy systems for the past 25 years on different designs, and today we will be understanding the modus operandi of cascading power generation systems. In this system, we are using water. The water is flowing down by the law of gravity. In this way, this power sector can be useful sector for the entire country for not using any fossil fuel, for eliminating the complete fossil fuel dependency and thinking of the people that fossil fuels are the only thing which can power the entire country or the planet. For this, we are using constantly thermal as 78% PLF, plant load factor, nuclear as nearly 90% PLF, but when we are talking about global warming, the global warming is directly and indirectly is causing so many problems for the green planet, and people are not getting free air, that is carbon free air, which was there before 1947, before the World War I and World War II. So in this way, when we are using the fossil fuels, the atmosphere is getting polluted, as well as the people in various countries are facing global warming. The temperature is rising, the ice is melting in the Arctic and the poles. So in this way, we will be losing so much fauna and flora. All these systems can be having a full stop in this particular innovation. We are concentrating on using water for cascading power systems, where the raw material is taken as water, the water from any water body. For example, if we are talking about a city, we are talking about the drainage water which is used by the people living in that particular city, and this water can be used as a byproduct for power generation. So in this way, now we will be explaining to you the concept of cascading power systems. In this, the power system will be utilizing the water which is thrown away as a waste product by the community which is living in one particular area. So to make that particular area free from fossil fuels and from nuclear power generation systems or solar or wind, this system is very helpful because it is using the used water or the drainage water. In this way, now we will be presenting you the system called cascading power generation. Please watch the video. It is being developed by people of India, made in India, and making in India is a concept. So we'll be looking at the slides of power generation in this session. So slide 1 will be calling the title as still water electrical generation. Still water in the sense there is no movement of the water. The movement of the water is totally zero. We are storing this water as a pump storage system. This is an improvised pump storage system where we will be calling this as still water electrical generation. This is designed by Chaganti Srinivas Bhaskar and Chaganti Bhala. Now we will be seeing the concept, the description of the pipe or canal. In this, there will be two sectors. One is D1, which is called as the water storage area, where the water is stored, and that stored water is made to flow out with a Venturi effect from D2. In the path of the flowing water, there will be turbines placed, and these turbines are bulk turbines, or we will be using a separate design to create that particular momentum into the turbine to rotate by the flow of the water, like the tubular turbine or the bulk turbine. So in this way, the D1, which is having length, width and depth, that is the 3-dimension figure. So in this 3-dimension figure, when we are talking about length, into width into depth is the storage area. So here one should understand the storage capacity and the pressure exerted on the bottom side of the reservoir from where the water is released into the Venturi affecting pipe, that is D2. D2 is having a lesser diameter, that is 8 meters in diameter, 8 meters width and 20 meters in length. D1 is 20 meters in depth, 20 meters in width, 80 meters in length. So the total pipe configuration length is 100 meters. So the injection part for this particular turbine to get rotated is totally 100 meters. The injection distance is 100 meters. So in this way, 3 crore 20 lakh liters, that is the storage capacity, 80 into 20 into 20. So 3 crore 20 lakh liters is the storage capacity of the D1 sector, and D2 will be getting 600 meter cube or 6 lakh liters per second flow with a Venturi effect of because the flow is more and the velocity is more. The velocity is having minimum to minimum 10 to 11 meters per second speed. The water is flowing out with 10 to 11 meters of speed, and in this way 6 lakh liters per second is flowing out from the D2. Thereby 6 lakh liters will be flowing out with 10 to 11 meters per second and flowing through the bulk turbine or the tubular turbine and rotating at 250 rpm maximum. Here head into flow into gravity into efficiency is the formula for power generation. So head is 20 meters and flow is 600 meter cube per second into gravity 9.81 into mu, that is the efficiency, generator, turbine and the transformer, all put together is 92%. So here we will be generating 105 megawatts of green electricity every hour from each sector. So one sector will be generating 105 megawatts per hour. In this way we are promoting this particular system as a cascading concept, and this cascading or a series of turbines placed in a series of pipelines will be explained in the next slide. The series of pipelines in the cascading system, one after another, that is one pipe, that is the D1 and D2, which is seen as a first pipe, is called the P1, and the second one is called P2, and the third one is called P3. Like that, on this particular cascading systems, we can generate 70 systems, that is P1, P2, P3, like that P70. So what we are explaining in this particular diagram is the series of turbines placed inside the series of pipelines will be helping to absorb the series of energy head what is there inside each pipe will be the cumulative energy of the total system. That is, if P1 is generating, D1 is generating 3 crore 20 lakh liters of storage water, then the P2 system will also generate a total system of 3 crore 20 lakh liters as storage, because here all pipes or the canal what we are proposing is identical in engineering design and diagram. So thereby each pipe will be holding the same capacity of the water and the head remains same in each pipe, that is the top surface of the water and the bottom surface of the turbine tail discharge is called the head. So here 20 meters is the total depth of the pipe, and when 20 meter is completely filled, 20 meter width, 20 meter depth and 80 meter length, that is width into height into length is a 3-dimension figure for each independent pipe or a canal with barrages of equal distance, will be having equal amount of storage space, thereby the pressure in each pipe is exactly the same in all the series of pipes. So here each pipe is identical in engineering sector, engineering designs, thereby the head is identical in each pipe. This is a very important point. Please note this. Now next slide we are showing. In this, the method to design right angle triangle for keeping the pipes or making a canal. So in this we have taken the total height of the vertical distance is from the ground level, that is a 0, to 125 meters. We will be constructing a particular wall or a ramp. This is supporting by pillars or brickwork or filling earth filling. So in this way, whatever is cheap and whatever is economical, we will be constructing the ramp in such a way that it will be formed as a right angle triangle. So on either side it is 125 meters height, that is on the left side and the right side is 125 meters height, and horizontal length of the top and bottom is 7000 meters, that is 7 kilometers. If we are cutting this 7000 meter and 125 meter height and length into a right angle triangle, this right angle triangle is the actual design for keeping a cascading power generation system. So in this we will be taking the height as the pumping height. The pump will be pumping to the maximum height, that is 125 meters vertical height, that is suction to discharge is only 125 meters. So when water is made to flow from the bottom to the top will be having a small reservoir. From the reservoir the water will be sent into the first pipe, and the first pipe will be completely filled and the water is released constantly into the following pipes which are arranged in series. On these systems we are working, and this is called cascading power generation systems. Now the next slide is keeping a method to design right angle for keeping the pipes or digging a canal. So either side it is 125 meters and the horizontal length is 7000 meters. So in this way, if we bifurcate into a right angle triangle, you will be seeing the slantingly slopily down area on this particular right angle triangle. The top sector is 125 meters and the bottom sector is ground level. So in this way, the right angle triangle is made to feel the slantingly slopily design of this particular system, on which the waterway is made to flow down by the law of gravity. So in the next slide, you can see fixing of the pipes on a right angle triangle. If we are fixing the pipe on the top of the 7000 meter, that is 125 meters vertical height, if we are keeping identical pipes as a series on the top of this particular 125 meters and 7000 meter length, the pipe will be like this. The placement of the pipes as in a series will be seen in this fashion, and in this fashion the water, when we are pumping to 125 meters, the water will not come out of each independent pipe, but we will be having lot of difficulties to push the water which is having an equal length, where the what I mean to say on this particular picture is each pipe is placed in the same angle and in the same height, in the same straight path. So here the flow of the water will be little difficult to flow out. So what we have to do is we have to make this particular sector to come down with the law of gravity. once the water is made to flow down, the water should not stop. So then what we have to do is, we have to place the pipes in a cascading, slantingly, slopily down ramp. The next slide will be showing you the difference of this particular system. In the first slide, the top placement of the pipes, and in the second slide, the slantingly, slopily down placement of the pipes is completely visible to the naked eye. So in this way, when we are placing this particular pipe in a cascading series on a slantingly, slopily down water runway, that is from top 125 meters to the bottom side of the ground level of the 7,000 meter distance, is completely covered with pipes. So there are 70 pipes, and one pipe is for 100 meters. So 7,000 meters require 70 pipes. So 70 pipes will be having identical, similar engineering, description and design. So each pipe will be having 3 crore 20 lakh liters storage capacity. So after filling out each and every pipe, then only the water is released through the Venturi effect to make energy by the flow of the water. Here one should understand, the water is flowing out, it is not falling. So the sector is totally designed for the flow of the water, but never for the fall of the water. So here one tail discharge is collected into the other and the head is formed, and then the second one will also discharge the same amount of water into the third one. Likewise, all the 70 pipes which are placed in series will be generating equal amount of energy. So in this way, each pipe, when it is generating 105 megawatts of energy per hour, 70 pipes will be generating more than 7,000 megawatts every hour, which will be sufficient for any city in India or elsewhere. Per hour, if we are generating 7,000 megawatts, that is clean energy, green energy. So here there is no problem for, there is no release of carbon or carbon related issues, that is pollution making issues. So here we don't have to worry, because the water is perennial, because everybody will take minimum to minimum 500 to 1000 liters per day. So a city which is having a population of 1 crore, when we are multiplying that 1 crore with 1000 liters, so that is the amount of flow which will be coming out into the sewerage area every day. So in this way, if we are in a position to cater to the needs of that particular sewerage storage facilities, that is, if we are in a position to control this sewerage water into a limited area and make energy and then recycle that particular sewerage water into drinking water or farm irrigation water, which is meant for irrigation purpose also, we can change the system in such a way that the same water can be used for irrigation also. So in this way, when we are in a position to generate 7,000 megawatts every hour, so in that, if we are in a position to take at least 2,000 or 3,000 megawatts of energy to constantly remove the dirt or the unrequired particles of that particular water, then make that water fresh and make the water flow downstream, so that the people who are having agriculture in the downstream can be benefiting of this particular system, or this water can be made to go inside the earth and make the water tables to get recharged. Thereby the aquifer what we want to build can be built in a very natural friendly ecosystem based systems. We can do it, because the water which is going inside the earth after getting purified will be further purified by the different layers which are there inside the earth, and the water which is not good for human use can ultimately be useful for agriculture purpose. In this way we can generate energy as well as we can make use of that drainage water by converting it into useful water and making it flow into the agriculture sector. So the next slide is for you to understand the series of pipes or a canal with 70 barrages, because here each pipe is identical in engineering designing. So each pipe will be holding 3 crore 20 lakh liters of water. So when each pipe will be having a head of 20 meters, then the flow is 600 meter cube per each Venturi pipe, thereby 105 megawatts, 105 megawatts per hour is constantly generating 24 into 7. Thereby the water is getting recycled again and again. Like this, each city and each village or each human dwelling areas can have enough electricity, forgetting all the fossil fuels or nuclear or solar or wind, because here the PLF, plant load factor, is more than 100%, and 24 into 7 generation is free because the water which we are using is used by the humans and thrown out as useless water, and this water is collected in the drainage system, sewerage system, and with this water, if we are in a position to manage the sewerage system, then there is no purchase of raw material or construction of dams for storing of the water. The water which is released every day itself is more than sufficient for this particular sector to give in 24 into 7 power generation for the benefit of the human development. So the next slide is when we are in a position to understand the measurements for understanding the water injection distance for each tubular turbine or the bulk turbine, the distance is 100 meters. So in this way 3 crore 20 lakh liters pressure is exerted on the tubular turbine or the bulk turbine. So in this way each independent pipe will be flowing out 600 cubic meters of water per second, so that all the pipes will be generating constantly and collectively throughout the day and throughout the year. This is going to happen for the next 25 years constantly, because the power plant life, that is the generator life, is maximum 25 years in this particular sector, because it will be generating 24 into 7. Non-stop generations are there, because the RPM is just maximum to maximum is 250, minimum to minimum is 150. So in this way we can design the project in such a way that low RPM generators are used. And here the most important thing is we are taking the weight of the turbine as 48 tons per 1 megawatt of generator. So here we are rotating 48 tons of weight per 1 megawatt. So in this way, when we are talking about 100 megawatts, the weight of the turbine is 4,800 tons. So when the 4,800 tons weight is getting rotated, kindly understand the torque of 4,800 ton turbine, which is 2.5 meters in diameter and rotating at 250 RPM. So in this way, the turbine, which is 4,800 ton and RPM is 250 rotations per minute, please understand the torque of the turbine and calculate for yourself what is the torque of the 100 megawatt generator, that is the PMG, or diode based, that is silicon exciter, internal exciter or external exciter, or we can have two exciters make sure that the power generation is constantly available to that particular stimuli. So in this way, when we are considering the torque of 4,800 ton and 2 meters or 2.5 meter diameter turbine, round spherical turbine, and when we are rotating it at 250 rpm, diameter is 2.5 meters and weight is 4,800 ton. So kindly understand the torque of this particular rotating machine. When 6 lakh liters per second or 600 meter cube water is flowing out with a velocity of 10 meters per second. So you have to calculate all these parameters and then come to a conclusion and then come and try to understand the design what we have made. Thereby all these particular designs are having a particular mathematical calculation. So if we are in a position to understand that mathematics, then for anyone it will be crystal clear how to generate cascading power systems and how we can eradicate the total fossil fuels or the use of coal or diesel or petrol or gas for any of these power generation sectors. Not only fossil fuels or nuclear, we can totally remove solar and wind, tidal, geothermal, etc. All these systems can be eradicated, and in these places, because the placement of this particular generator turbine is also having limited space, limited area and unlimited amount of energy. So this is what the design is for catering to the needs of any city or any village or any human dwelling area on this particular green planet. So the next slide is, this is a section of the pipe where the water will be stored. So you can see the depth of the pipe as 20 meters, the width of the pipe as 20 meters, the length of the pipe as 80 meters. In this 3 crore 20 lakh liters of water is stored, and please understand the weight of the water, that is 3 crore 20 lakh kg pressure, that is 3 crore 20 lakh liters, in the sense 3 crore 20 lakh kilograms of weight is there on the turbine when we are discharging 600 cubic meter or 6 lakh liters per second with a velocity of 10 to 11 meters per second velocity flowing out from the venturi pipe into the turbine blades. So the next pipe is, you can see the next picture as the next slide as the turbine is placed in the path of the flowing water. The turbine is a tubular turbine or a bulb turbine or a turbine which is designed for the flow of the water. So water from one pipe will be flowing out into the next pipe, and in this flowing pattern, please understand, when the velocity is more, the water flowing out with 10 to 11 meters per second and the volume of 6 lakh liters per second will be a great difference on this particular system, because the width of this particular pipe is 8 meters. So the loss of energy by flowing out, that is the fluid loss or the head loss, is very minimal. That is, if we are in a position to take minimum to minimum 3.5 meters head loss, still then the water which is flowing out will be having enough energy to rotate this particular turbine with a RPM of 250 or 150 RPM. So here we will be using controllers to make sure that the voltage is stable and the heads is stable and the amps are stable. So when we are making a controller to take over the generation, thereby the heads is 50 heads in this particular system when we are designing for India, and elsewhere it can be 60 heads. So this will definitely have a linear effect on this particular system, because the flow is linear in motion and the flow is equal in all seasons, all the 365 days. So because when we are having lot of sewerage water collected in the area, then we will be using this water to make the turbines rotate by the flow of the water. This you should understand. We are taking the flow of the water which is running inside the pipes. So the next slide is the series of turbines in the path of flowing water. Here you can see each turbine is placed at an equal distance, which is seen clearly in this particular sector. That is 80 meters is the storage area and 20 meters is the water flowing area. So when we are talking about 80 meters, all 80 meters is totally saved. That is 3 crore 20 lakh liters is saved in each sector. And when 3 crore 20 lakh liters is having an opportunity to flow out, only 600 meter cube per second water is flowing out from 8 meters diameter with 10 to 11 meters per second velocity. So here one turbine discharge, tail discharge is collectively collected inside the second one. When the second one is completely filled, the second one will be discharging 6 lakh liters or 600 meter cube per second into the second turbine. The second turbine tail discharge is again collected. In this way, all the 70 independent pipes which are called as reservoirs as D1 will be storing 3 crore 20 lakh liters of water, and 3 crore 20 lakh liters pressure is there on each generator and turbine. Thereby 105 megawatts of energy is created and generated and made available for the human utility, because each turbine is having 150 RPM or max 250 RPM, but the head is the same because the depth of the pipe is 20 meters in each and every independent pipe. Thereby head is normal, flow is constant, head is constant, gravity is constant, and efficiency is also constant. Thereby 105 megawatts of energy is coming out of each generator turbine. So in this way, the cascading series of power generation will be useful for eradicating the global warming and the usage of fossil fuels from this earth, and we can use this particular system to any country, anywhere on this particular green planet for making people happy. So the next slide is, here we should understand how we have to make the right angle triangle. So in this way, the right angle, when we are talking about this particular thing, the vertical height is constant, the slantingly slopily down area, the hypothesis, is also constant, and the base area which is on the bottom side is also constant. So in this way, when we are talking about a right angle triangle, please understand the slantingly slopily down design for the water to flow down from the top to the bottom by the help of gravity. So in this way, in-pipe cascading electrical generation is a perfect power generation system because we are using less amount of water, little amount of space, and maximum amount of power generation. So this way we don't have to accumulate water in large areas as seen in the dams. Here we are having limited area and limited water and unlimited amount of energy, that is green energy. So the next slide is, here we will be taking the bottom side of the right angle triangle as the base reservoir. The bottom side reservoir is always full. The bottom side reservoir is 40 meter width, 2 meter depth, and 7,000 meters length. So in this way, the water which is there inside this bottom reservoir will be always perfect in salinity. That is the sewerage water will be totally useful as it is, because here we are not changing the water pH or any other system. So we are removing only the solids, but the little solids which are there or which are suspended inside the water will not make much difference. So here we are making the water to be always available for the pumps in this particular area to pump the water to 125 meters. For pumping we will be using renewable energy systems, like we will be collecting the energy generated by making a particular waterfall as a constant supply of energy into the batteries. In India, there are so many waterfalls which are there hidden inside deep structures of the forest. So here, when we are in a position to take that particular energy by keeping a small power plant and recharging the batteries by this power plant generation, and the batteries are transported to this particular sector where the pumps are connected to this particular battery and the pumping is constantly done. So here we are using the base reservoir as a water storage area. So the next slide is the pipe or canal for making the water flow down by the help of gravity, as explained to you in the beginning. So we are making the pipes fixed on a slantingly slopily down area of the right angle triangle. This is the most important part, because when we are making the water to flow down by the law of gravity, then one pipe discharge should be collected inside the following pipe. In this way, gravity will be helping down the water flow. In this way, we will be storing the water in each pipe. By the flow of water, we will be generating energy. So in this way, the next slide will be giving you a particular observation that water getting pumped from the base reservoir to the top water tank, acting as a water storage area on the top side of the right angle triangle. So in this way, the bottom side water is constantly pumped up and a little storage area of 1 crore or 2 crore liters water is always available. Thereby the water will be flowing down by the law of gravity from one pipe to another pipe. So the next figure is, you can see here water is coming down from one pipe to another pipe by gravity, passing through the tubular turbines or the bulb turbines or the turbines designed by me. So in this way, this is a cycle, that is, water is pumped from the base reservoir to the top. The water which is pumped from the top will be coming down by the law of gravity and falling into the base reservoir. The base reservoir is again getting full by the discharge of the top side water. Thereby the water is recycled 24/7, generating green energy. So in this way, this picture will be showing you the circular motion of the water flowing in a cyclic manner. So next system is dimensions of the pipe or canal. This you should understand, because if we are talking about head, we should understand the dimension, because when we are talking about a pipe which is 20 meter in depth, 20 meter in width and 80 meter in length, the 3-dimension figure will be having full of water. So the top surface of the pipe and the bottom surface of the pipe is the storage part for each independent and individual pipe. Thereby every pipe will be having 3 crore 20 lakh liters of water. The top surface of the water and the bottom surface of the water, which is the tail discharge. The bottom side is the tail discharge and the top side is the pipe which is fixed on the right angle triangle, slantingly slopily down area. That is the head, because where the turbine is, to the top side of the turbine, what is the height of the water? That is the top side of the water, and the bottom tail discharge is called the head. So here you can see every pipe is constantly having 3 crore 20 lakh liters as the storage capacity. because 1 second inlet and 1 second outlet is always equal. So 6 lakh liters are going out and 6 lakh liters are coming in. That is 600 meter cube inside, 600 meter cube outside. So the pumps are pumping 600 meter cube per second and the pipes are discharging 600 meter cube per second. So here, when we are in a position to match the inflows and outflows equal, the head and the discharge is equal. So thereby the generation is also equal in each and every independent pipe. So the next slide is power generation calculation, that is head into flow into gravity into efficiency. If we are taking the head as 20 meters and the flow as 600 meter cube per second and 9.81 as gravity into mu, that is the efficiency is 92%, then 105 megawatts of energy is generated per each and every independent pipe. So in this figure we will be calculating how much energy we will be generating from 70 pipes, that is each pipe 105 megawatts into 70 pipes which are there in series. So it will be more than 7000 megawatts of energy. So every hour when we are getting 7000 megawatts, so that will be equal, that will be the required amount of energy needed for any developed city in India. So in this way the generation can be made by the usage of the sewerage water which is going out into the sewer by the population living in that city. Thereby the water which is used for their general application can be converted into power generation sector. So the second slide, the next one is the pumping calculation. Here every second we will be pumping 6 lakh liters as the pumped water. So we will be pumping it to 30 meters, and here when we are talking about 125 meters, the stages is 5. So we will be having 5 sections. Water is lifted to 30 meters and from 30 meters again next to 30 meters, like that there will be 5 independent sections. So the water is lifted in 5 stages to reach 125 meters. Each pump is pumping 5 liters per second. So when we are talking about 1 HP pump which is designed by me, it will be pumping out 5 liters per second and the head is 30 meters. The power consumption is 1.6 amps to 1.8 amps because of the variation, so and losses. So here when we are talking about 1,20,000 pumps which can be aggregated as 6 lakh liters per second, because each pump is pumping 5 liters per second. So 5 liters into 1,20,000 pumps is 6 lakh liters, 12 5s are 60. So power required to pump water, total number of pumps used is 1,20,000 numbers, and each pump is consuming 1.6 amps into 440 volt into 1.7 service factor by 1000 will be giving you the amperes. And in this particular system, when we are talking about the amps into volt into service factor by 1000 will give you the total number of kilowatt consumed. So when we are talking about kilowatt consumed, each one sector, that is 30 meters, will be consuming 143.6 megawatts. 143.6 megawatts per 30 meters every hour. Thereby the 5 stages will be consuming 718 megawatts per hour. In this way the 5 sectors will be having 1,20,000 pumps per stage, that is 1,20,000 pumps into 5 stages, that is 12 5s are 60. So in this way 6 lakh pumps are used for pumping 6 lakh liters of water to 125 meters of vertical height. And now when 6 lakh liters are pumped to 125 meters height, the water should come down. So in this way the water is stored in a tank which is constructed on top of 125 meters, and 1 crore or 2 crore liters is the storage capacity, and from this we will be discharging 6 lakh liters per second into the pipe. So in this way we will be sending 6 lakh liters per second into 3600 seconds. So in this way, when we are talking about huge power generations, so every hour when we are in a position to consume a huge amount of water, in dams it is not possible, because the rain what we are getting will not be having so much of storage area, and the catchment area will not be always getting the rain, and the dams will never be full, as they are completely filled only for the 3 first months, that is the rainy season. Thereafter in the winter and in the summer, the dams will be letting out the water for irrigation and power sector, power generation systems. Thereby the hydro sector is not 100% catering to the requirements of the country. So in this way, when we are talking about dams, the dam should be used for cultivation purpose and never for power generation. The power generation systems can be developed in this way. Thereby the dam stored area, the water, can be used for irrigation purpose. Thereby the food production will be increased, the irrigation time will be more, and we can have more crop and more irrigated land for getting water. So in this way we can use these cascading systems as a pump storage system. This is a improvised pump storage system. So in this way the cascading systems is a boon for the power generation sector. So the next slide gives you water filling water in each independent section, that is total number of pipes or canal barrages on the parabola is 70 numbers. Total length of parabola curve is 7000 meters. For every 100 meter, one independent power generation sector having 100 to 105 megawatts generating capacity, that is the bulb turbine or a tubular turbine, will be designed for 100 or 105 megawatts capacity. Each sector length is 80 meters, width is 20 meters and depth is 20 meters. So thereby 32,000 cubic meters or 3 crore 20 lakh liters per sector is identical in design. So for each sector, inflows, outflows, water pressure, water velocity are always the same. So in this way, when we are talking about 70 sectors, the 70 sectors will be constantly generating energy, because water is flowing down from one sector to another sector in equal systematic way, that is 600 meter cube from each venturi pipe passing through the turbines. So the next slide is power generation each sector. Power is equal to head into flow into gravity into efficiency by 1000, that is P is equal to power is equal to 20 meter head into 600 meter cube per second. Flow is the flow or discharge per each venturi pipe outlet into 9.81 gravity into 9.9% efficiency by 1000 is 105.948 kilowatt hour per hour, kilowatts per hour, that is 105 megawatt per hour is generated constantly from each sector. Thereby 70 sectors will be generating electricity non-stop all 365 days and for 25 years. So the next slide is total power generated in 70 sectors, each independent sector 105 megawatts. Thereby 70 independent sectors will be generating 70 sectors into 105 megawatts, that is 7350 megawatts per hour is generated constantly. So when we are talking about 7350 megawatts per hour, and when we are talking about the pump consumption is 718 megawatts, the generation is 7350 megawatts. So kindly understand the difference of the pump consumption and the power generation. The pump consumption is totally managed by battery systems which are recharged and made available to the area where the pumping is required. like what you are getting coal from different areas and supplying to the coal generating systems, that is the thermal systems where it is utilizing coal. Coal is dug somewhere, transported somewhere, and totally when we are talking about coal, the coal is coming from various areas and dumped into one particular yard. From there the coal is made to flow inside and fall inside the burning area of thermal sector. So in this way, when we are transporting huge amounts of coal, why can't we transport a full charged battery? The battery is lithium titanic, which we have designed. The battery can be recharged in 8 minutes. And when we are talking about 718 megawatts or 720 megawatts, the battery which is getting recharged by the waterfalls which are available in various parts of the country. In deep forests there are huge waterfalls, and if we are in a position to tap that waterfall and make energy then and there and store this energy generated into the battery system, the batteries are charged every hour from these particular water falling areas. Then the batteries are transported to this particular sector where the pumping requirements are having huge power requirements, that is 720 megawatts. Thereby, when we are talking about this particular sector, the pumping is also done by renewable energy systems. Thereby, we will be completely eliminating the coal, nuclear, solar, wind, etc. and depend on hydro, that is the sewerage water which is made available by the people who are living in that particular city or that particular area. So we will be concentrating only on the sewerage water, which is not used by anybody in the world, and we don't have to use dams for power generation. So next slide is total power for sale. Power consumed by the pumps is 718 megawatts per hour. Power for sale every hour is 6632 megawatts or 6632,000 kilowatt per hour. Suppose if we are selling each kilowatt for 50 paise or 1 rupee, we will be getting a revenue of in 5 to 6 years we can repay the loan what is taken by the company. So next slide. This is an example for the power generation on a parabola which is designed with the forming of a right angle triangle. The right angle triangle is little deviated and formed a parabola. So in this parabola, water is coming down by the law of gravity from one turbine to another turbine. In this way, water is flowing down and making power. So the next slide is, this is the CFD of water flow. Here, when we are talking about the water flow, you can see the water velocity and the water flow which is coming out of the pipe. Thereby, each pipe will be having a similar effect of water flow pattern, and the water flow which is flowing out will be seen like this inside the pipes. So the water is flowing inside the top reservoir. The top reservoir, when it is filled, it is letting out the water inside the first pipe. The first pipe is getting constantly filled. So in this way, when we are talking about filling the first pipe, kindly see the water particles, how the water particles are flowing and getting filled inside the pipe. The water is getting stored the turbine which is there in the path of flowing water is not rotating. So the water is constantly coming down into the first pipe by the pumps. The pump is pumping 600 meter cube of water per every second, and water is getting collected, and then once the water is filled, the water is made to release. The turbine rotates by the flow of the water. The water particles which are flowing out is constantly getting collected inside the following pipe, which you can see very easily to the naked eye. It is visible. So the second pipe, when it is constantly getting filled, still the first turbine is rotating and generating electricity, and the second pipe, when it is completely filled, is making the water flow out. Thereby the second turbine is also getting rotated. So these are the parameters by which we can see the water particles flowing inside and outside of each generator turbine. So this is an example for you to understand the concept of power generation in a cascading method. So we are taking series of pipes which are placed on a parabola as shown to you previously. So in this way, when we are talking about as an example to make you understand, the water is pumped in this particular sector to 70 meters. From 70 meters, the water is flowing down by the law of gravity and touching the bottom side of the end part, that is to the ground level. Now you can see the first turbine which is fixed out of the pipe, outside the pipe, and water is flowing out inside this particular system. Then the water is getting collected from P1 tail discharge into P2 tail, into P2 reservoir, that is P2 pipe, which is also having equal amount of storage area, that is 3 crore 20 lakh liters. So in this way, one pipe will be discharging water into the other pipe. So each pipe will be flowing out or discharging 600 meter cube per second water. So in this way, each pipe will be storing 3 crore 20 lakh liters and discharging 600 meter cube per second. Thereby each pipe will be generating 105 megawatts of green energy all the time, every hour, all 365 days equally, because the RPM of the generator is maximum say 105 or 150 or 250 RPM. The turbine RPM is also matching 150 or 250 RPM. So in this way, with less RPM and maximum amount of power generation, thereby the maintenance part is very little on this particular issue. So we will be generating 105 megawatts of energy per each and independent pipe. In this way, you can see 70 pipes which are there on this particular parabola, and in this example we will be showing only 20 pipes. So in this way, this is an example to make you understand the water flowing pattern from P1 to P20. The bottom side of the P20 discharge is the bottom side reservoir, which is always full of sewage water. In this way, we will be generating 105 megawatts of energy per each independent pipe. So this is how we have to understand the cascading structural power generation. The power generation will be having, the power generation sector will be having constant amount of power available at all seasons, because the base reservoir is always giving the water for the pumping sector. The base reservoir is always getting all the water discharge which is done by the sewerage collection point and the base reservoir is always full. Thereby the water availability to the pumps are 24/7 constant. Thereby the power generation is also constant in each and every sector. The base reservoir is always getting filled every day by the sewerage water, which is let out by the people which are dwelling in that particular area. Now you can see the section of this particular area very clearly, how the water is lifted from the base reservoir. Now the water is getting lifted from the base reservoir to the pumps. The water is made to flow into the top reservoir. The top reservoir is getting the water from the pumps, and the bottom, the first pipe is getting filled by the pump, and once the bottom first, that is the very first pipe which is below the reservoir, is completely filled, now the water is flowing out into this particular first turbine. The first turbine is getting rotated and the tail discharge is getting collected inside the second pipe. The water is getting pumped in constantly. The water is flowing out constantly from the turbine tail discharge into the second pipe. So the second pipe is getting filled, and once the second pipe is completely filled, kindly see the second turbine is also getting rotated by the amount of water which is flowing out, that is 600 meter cube per second. Thereby the first turbine is constantly getting rotated. The second turbine is also getting constantly rotated. So in this way the picture is very clear. So in this way we will be showing you an example where a similar system is made, and this is made in the flowing pipe. The water is made to flow out, and in the path of the flowing water a turbine is fixed, and the generator is there on top of this particular pipe, because this is only an experiment. So in this way, when we are talking about an experiment, the experiment is done here by using a spherical turbine. In this spherical turbine, the water is made to flow, and the turbine rotates by the flow of the water. The water velocity will rotate the turbine. Thereby we will be scavenging the energy what is there inside the flowing water, or we will be harvesting the energy which is there inside the flowing water through the help of this turbine, and this turbine will be rotating and generating energy. In this way, this is an example for people to understand the series of turbines fixed in the path of the flowing water, where the water is flowing, and with the flow of the water head, the flowing water head will rotate the turbine. A series of turbines can be fixed in the path of the flowing water, and when we are talking about series of turbines, the series of turbines can be harvesting, or it can make collective power generation. Thereby we will be generating constantly the required amount of energy, and in this way we are showing you the system how a corporate company, that is Cow and Calf Dairy Farms Limited, which is located in Hyderabad and which is in the ROC, Register of Companies, registered in 1998. So we are doing a particular system in this particular research, as you can see by this particular effort, that in-pipe cascading systems will be generating constant amount of energy throughout the year for any length of time. This is designed by Chaganti Bhaskar and Chaganti Bala. We are grateful to the people who are seeing the video and understanding the concept of cascading power generation, Thereby global warming is totally eradicated. We don't have to use fossil fuels anymore. So in this way, nuclear power, fossil fuels can say goodbye, and we don't require the help of these two sectors anymore. Thereby the planet will be green, the planet will be self-sufficient, full of energy. So in this way, we people are contributing to the development of human and human evolution. Thank you.